Cool, thanks. Alec previous presentation was really good, so I think we're going to take a step back and focus a little bit more on data development and the techniques and tools to really kind of put some of those things into place. But the title of this is called The Past Meets the Future, Integrating Evolving UAV and Remote Sensing Technologies into Cemetery Mapping. And like we heard before, cemeteries have significant cultural, historical, genealogical value, but are typically poorly documented. And the example we're going to use today is we're going to talk about this lack of documentation and why there's just a need for some of these technologies to actually see where people are, buried in the ground. They're typically inaccessible documents, and they're in a state of neglect. And since I gave this as a transportation presentation before, there's some definite relationships with transportation planning. You can see one here from the Maryland Department of Transportation, and then kind of more recently with African American grave sites around the Capitol Beltway for road widening plans. So you can see the direct implications of cemetery and detecting these possible places with respect to transportation planning. Now, our current needs, and these were kind of the needs that we're working on with the particular project, is that the creation, collection, cataloging of high-quality cemetery data. It's a patchwork and circuitous process, accumulation of existing records, death notices, and census information combined with the tacit knowledge of church members. So we're going to talk about some of those church members who are getting older and older and not really passing that information down to the younger generation. We also are concerned about the detection of unmarked graves in historic cemeteries in fear of kind of literally digging people up or disturbing remains because they're not because they're poorly documented. So we're looking at geospatial techniques and tools such as GIS, GPR, UAVs, artificial intelligence, machine learning, to look at transformative tools to not only teach our students, but to really help some of these communities that don't have access to these tools. I'm a professor, graduate coordinator at North Carolina Central University. We're HBCU or MSI located in Durham, North Carolina. We're largely focused on public service, so I think this talk and this research falls into that. We have our department is called Environmental, Earth, Geospatial Sciences, which was consolidated from geography and environmental science a little before I got there in 2010. And we have about 50 BS students, about 20 MS students, and we recently began online BS and MS programs. So we have some of our students here, some of whom participated in the online program. Our Herb Stout Award winner actually this year was an online student who lives out in Nashville and has done such a great job. She was our Herb Stout nominee. But our work has a particular focus on data development and data development standards, such as geocoding, adding XY, digitizing GPS, georectification, and more recently, UAVs, image extraction, AIML, GPR, which really weren't big when I started doing GIS at ARC Info Command Line in the late 1990s. So there's been a learning curve for me to kind of figure out how to use these and integrate these into some of my specialties, as well as metadata standards to catalog data collection techniques. Our department, we've had recent awards from NSF, NASA, Federal Highway Authority, DOD, and a few from NCDOT, and a lot of our graduates are going to real estate firms, EPA, NCDOT, local government. Some of them are here. And we've placed students at North Carolina A&T, North Carolina State, UNC Charlotte, UNC Greensboro, and another one here at East Carolina. So the work that we're doing is in Chapel Hill with Hickory Grove Missionary Baptist Church. It's a predominantly African American church located on the western edge of Chapel Hill over near Alamance County. And the DEGS, our department, and the history department, we're approached by the Office of Community Engagement and Service about aiding in the technology or any technologies to map their 1 acre cemetery. And since I hadn't really done this before, I think I could figure out and manage an acre and, basically try to map the place, literally. You can see right here, this is the Hickory Grove, not a professional map here, but Hickory Grove. And then the cemetery is located a little to the southeast. It's kind of, you can barely see the church from the cemetery, but it's over here, and it's kind of evolved in the years since the 30s when there were some buildings. I think there were classrooms or something sitting on the site. And so our history liaison, the person we work with in the history department, has provided us with some records, and you can see some of the Excel record spreadsheets that we have. There's some scanned PDF documents of some of the death certificates for some of the people who are interred there as well. And so it's just a whole bunch of records. You can see there's a lot of question marks sitting here, and eventually the goal is to kind of create a one-to-one relationship between these plots that we heard about just now and the people that are there. And so I heard about some of the complaints, how things aren't in lines. Well, you'll see what it looks like, what we did here. And so some prior work in cemetery mapping, I just did a little research to see what people had done before. One was done in Minnesota, where they converted handwritten cemetery records into Excel, and they created unique IDs using, lots, sections, and plots. We're not even there yet. And they use GPS and laser rangefinder for accurate locations. There's been another one in Richmond. There was about 15,000 flights. This a little bit more aligns with what we're doing, where they use UAV flights with the DJI Mavic 2 Pro at an altitude of about 175 feet with an overlap of 80%. And they created orthomosaics and digital surface models to look for sync point features using hydrology tools, which I thought was kind of interesting. And then there's been some GPR processing interpolation based on AIML, and our GPR just came in before, last couple of months, so I'm still learning how to do that. So a good end goal would kind of be to explore how AIML, deep learning, can automate GPR processing and, more importantly, kind of image and feature detection. So you can see some of the work that we've done, some of the previous work done before. This is the African American Cemetery located right off of Interstate 64 in Richmond. And then this is what it looks like here. And then you can see the other cemetery on the other side. So you see some of the kind of logistical challenges that we deal with. But this is the cemetery we're looking at here. 1 acre. We ran some UAV flights in mid-October of 2024. We purchased a Mavic 3 Professional, and we ran it with about a 75% overlap, and we captured about 600 of these images. You can see what the cemetery looks like, and you'll see what it looks like from overhead, and it'll look pretty different. Some other things that are happening, it's being overrun by the actual forest to the south, so you can see some of the graves which are kind of being overrun by the forest, and it's not really well kept because a lot of the members of the church are elderly. You can see in blue, Dr. Johnson. He's kind of our history contact, so he does a lot of oral histories. He's really well versed in story maps about telling some of the stories about our African American neighborhoods around the NCCU campus, as well as some of these cemeteries. So he's kind of talking there. He's kind of highlighting some of the work that he'd done before, and you can see the forest, which is starting to overtake some of these graves. And then we're just kind of highlighting that again. The deacon of the church is in the maroon. He's a Eagle alum, and his wife to the left was a dean at our nursing school until about 2010. So we're kind of excited to have the Eagle connection, and we're connected through our Office of Engagement, who I hadn't really worked with previously. But these are just some of the images that we took. I'm kind of new at the drone, even though I've got my Part 107, so I just go and take as many pictures as possible and let Drone to Map kind of kick out the ones it doesn't like. And so I let my students kind of do all the visualization, since that's not my best suit. So we just went and collected a whole bunch of students. We, collected them, straight down at angles, so we can kind of start to create and, develop some 3D imagery and movies and visuals that I think people would like that aren't necessarily computational tools. We've got tons and tons of pictures. I could show you these all day here, but at the end of the day, we use Drone to Map to create a composite orthorectified and digital surface model with a resolution of about 1.44 centimeters, which we liked. And when we kind of zoom in a little bit, these are some of the features that we're looking at. And then you can start to see, obviously the trees are going to pop here in this digital surface model, but you can start to see some of the headstones pop a little bit with some of the elevation. We also created some 3D imagery, 3D imagery and 3D fly-through. I'll show this at the end because this video isn't working here. Or maybe it wants to, I guess not. But some of the AIML work we're utilizing thus far is that we're using unsupervised ISO clustering on true color imagery for 10 classifications. So we're trying to identify possible grave sites that map signatures, because when we look to the southeastern portion of the graves, of the cemetery, there's like little rocks, headstones, or typically there's nothing, and then it's being overrun by the forest there, and so that'll create another set of challenges, especially when inspecting it from above. And so we ran some ISO clustering on just some of this true color imagery using 10 classes in basically 3D vector space. And we identified or looked at some possible places where there might be graves that just match the colors, what our eyes can see as well. The next thing what we're looking to do is we purchased an infrared UAV. That's just, I've only used it a couple times, which I think is interesting, but it's a Mavic 3E, which has multispectral capabilities, and so it can create NDVI. It's got some red edge capabilities above and beyond what our eyes can see, because our eyes can kind of make some of these things out. So we're looking at mapping these in 5 dimensions as instead of 3. And so we're looking at more wavelengths that can possibly elucidate patterns above and beyond visible light to create power visualizations and identify possible grave sites. So this is a picture of our campus there, so you can see the NDVI imagery that was created. And then for our parking lot right here, because typically it just all looks green to me, or pretty soon it's just going to look all green to me. So looking at plant health, especially in that cemetery, might be interesting and kind of foster some new patterns. Really quickly, I went and flew it just a little bit, but it was really early in the morning, and so you can see some of the shadows that I don't necessarily like. So I'm going to kind of arrange a site visit with some students and go back in the middle of the day, especially the same time of day when our original imagery was collected, to look at these. And so you can start to see, when we run this ISO clustering, some possible locations in 3, 4, 5D vector space. The other thing that I'm trying to learn, since I'm getting older, I don't want to learn new stuff, but I'm kind of forcing myself to, is ground penetrating radar. So we recently purchased a ground penetrating radar to identify potential grave sites and confirm sites using unsupervised or supervised techniques. So previously I talked about the unsupervised techniques using the ISO clustering, but we know where graves are, so we can look at digital signatures of graves and just look for the same thing using supervised techniques, and that would be a great project, as I'm looking at some of my students and postdocs right here. And so, but what I also did was we went to the cemetery, and we used the GPR, where I found some definite digital signatures of grave sites that were located right there. And these are represented by these parabolas. I need to better learn how to GPR, so I'll talk about that in my conclusions. And then I walked in the area where they were much older. They were from the late 1800s, early 1900s, and they didn't have markers for them. And so I also found some of these parabolas. If anyone had noticed that the DEM, or the digital surface model that was created, that was kind of downhill. So I would imagine those remains are a lot closer to the surface, because there's been so much erosion and weathering in that part of the cemetery. But you can definitely see some signatures represented by these parabolas there as well. They're probably a lot more scattered, just because the caskets have long collapsed or whatnot. So we're pretty excited about some of these results. We really want to go back at a later time. Our future work, and I've kind of broken these down into kind of some of the analytical things, some of the personnel things, and then some of the practical things that Alec talked about before, is that we want to create high quality elevation data to identify depressions, collapses in ground. So I want to better work with our drone to create those, because I've got trees from an elevation of 175 meters. So I want to create a little less contrast so we can identify some of those. I want a methodology to tease out grave sites in areas being overtaken by forests. I'm always open to ideas on that one. And then we're going to look at supervised classifications to identify existing grave sites and look for similar patterns among and along our visible and near-infrared wavelengths using our new drone. Some other things, someone such as me needs to better learn how to use the GPR unit. And so I recently purchased a GPS, so a GPS unit that connects to our GPR, so I can create basically maps. And so instead of walking along swaths, I can create maps that can be geo-rectified and placed on top of our GPS. And that's something I really look forward to, with slices at particular depths. And we created at a resolution, so we're looking at like archaeology and potential, drugs or whatever. That was the application we bought for, instead of some of the lower frequency that looks for like bedrock and other features that are a lot lower. And so, like I said, we want to create grids using GPR, GPS integration that can be superimposed on real-world data. And with an end goal, what we want to do is create polygons within a GIS to denote verified grave sites, because probably 3/4 of it has been verified, but there's a whole quarter of it we have no idea where it is, and it's just kind of a mismatched process there, where it's hard to tell. There's no lines, there's no plots. What you saw before with Alec in the previous presentation is light years ahead of what we're working with here. And then the linking of these polygons to an ID, a unique ID for the deceased. And then at the end, display this within the confines of a GIS, online maps, story maps, web experiences, dashboards, so we can highlight these to the public, which is, to me, is of utmost importance. And our conclusions, we've got powerful visualizations that allow for various representations of cemeteries that can be put in GIS and utilized, displayed geographically. Mapping, when working with cemeteries, is sensitive work and needs to be receptive to the church's needs. So we went back in October, and it's, I want to make sure we're doing this okay. I don't think people want someone like me just showing up with a bunch of equipment that looks like a lawnmower and, flying drones there. So people need to be receptive to those. The first time we went, we had a whole group of people go, and I want to make sure we've kind of have standing permission, or, permission when we can go at certain times, so that we're not kind of stepping on anyone's toes, and we're being receptive to what they want. And so the work can take a lot more time than we expected, just to get some of those permissions. And then we hopefully anticipate future work in transportation planning, better identify regions that may inhibit construction, as well as some of these other things. But this is my contact information here. I need to acknowledge my funding from folks such as NASA and a couple of NSF grants as well as some of the people that are involved on the project. And then the last thing I'll show here is the video that was created by our student, Baron Allison. He is hopefully soon to be a graduate student here, but he is my resident Make Neat Things. And so using the imagery, he created a little fly-through that we kind of posted on YouTube, using all the imagery and all the elevation data. So I don't know how to make any of this stuff. He's he's really good at it. So when we need any visuals or 3Ds or fly-throughs, I send it to him or someone else. And this is the area down here where there's not a lot of markers, so that's kind of the area of concern. Okay, cool. So that's about it.